My name is Mashudu Mamburu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So we're going to have our lesson in technical science as indicated, hoping that you have been ready preparing for paper 2. At least you had ample time to revise. We're hoping that you will do well when the paper comes. We're going to focus on two major topics in paper 2, which is organic chemistry and electrochemistry. So this will be our focus. Remember, learners, paper 2, what are you expecting tomorrow? Metal materials, you're expecting 47 marks. And then chemical change, you're expecting 28 marks. So when you add the two, they will give you a total of 75%. 75 marks. Remember, it's 75 marks you are writing for 90 minutes. So you must time yourself well there and ensure that you spend your time correctly. I will usually say use 1,2 minutes for every 1 mark. So you can look at the question and allocate sufficient time so that you don't lose yourself some marks during the process. Now, as I indicated already, that I will be dealing with these topics under paper 2. We are saying we will do a question, first question, which usually is question 2, which is naming of organic molecules and isomers. And then question 3, we're expecting physical properties. And then the question 4, reactions of organic molecules. So, and then question 5 will be electrolytic cell and galvanic cell, as well as alternate energies. So those are the aspects that we're going to deal with today on this lesson. I hope you are ready. Last year, at the end of the year, this is how learners performed. You can see question 1, which is our multiple choice questions. It was a good average of 52%. And then 45% for question 2, which is naming of organic molecules and isomers. Question 3, which is our physical properties, your melting point, boiling point, vapor pressure, and viscosity. We had 37%. So you can see that it's decreasing. Question 4, which is reactions of organic molecules, learners performed at 27%. So it's one of the topics. In fact, it's the most failed topic. Many learners didn't pass this topic. I'm thinking that this lesson is going to help you so that you get total in question 4, because really it's one of the simplest questions. So just relax and join me. I hope you have something to write your notes. You're going to do that. Whatever you want to jot down, you can write down. And then question 5, 31%. Question 6, 29%. So total on average for technical science last year, it was 36%. And we are hoping that with this cohort of yourself, we're going to get even better marks for this year. Now, under organic molecules. So this is taken straight from the exam guideline to say under organic molecules, the first thing that you must know are the definitions. We are emphasizing definitions, and we are saying always use exam guideline to define. So use definitions from the exam guideline as compared maybe to textbooks and all other sources. It's better to use the exam guideline, because during marking, we'll be utilizing the very same exam guideline. So the definitions you're supposed to know is you must be able to define what are organic molecules, what is homologous series, what is functional group, what are hydrocarbons, what are saturated. Remember, hydrocarbons, we have saturated and unsaturated hydrocarbons. You must know the isomers, structural isomers. We are having chain isomer, positional isomer, and functional isomer. So you must as well be able to know primary, secondary, and tertiary alcohols, not only alcohols. So you must know primary, secondary, and tertiary alcohols or haloalkanes. So you have to know those and be able to define them, and haloalkanes as well, primary, secondary, and tertiary. Now, for our lesson for grade 12, we do 9 homologous series. So we're going to focus on the 9 homologous series that you must always remember. I usually will say AAA, which is alkanes, alkenes, and alkynes. So you have to know those 3. Those first 3 are what we refer to as hydrocarbons. And then I will say after that, Hake, so that you don't forget them. Hake stand for haloalkanes, aldehydes, ketones, and esters. So those are another group of organic molecules. And then we talk about A and C, which is the alcohols and carboxylic acid. So those are the 9 homologous series that you focus on. All the questions that you will get will be based on these 9 homologous series. So it's important that you know this as your foundation, all these homologous series. Now, for each homologous series, we are saying you must be able to know the functional group, and then you must be able to know to write down the molecular formula. In fact, you start with the general formula. You must know the general formula, you must know the molecular formula, you must know the structural formula, as well as condensed structural formula. Because if we look at some of our papers, you will see that we have some condensed structural formulas. So it's important that you must know all these 4 types of formulas. To say general formula, molecular formula, structural formula, and condensed structural formula. So those are the formulas that you know. And we're saying for each of these homologous series, you must be able to write down general formula, molecular formula, structural formula, and condensed structure. And listen to the question to say, is this question looking for molecular formula or structural formula? So that when you respond, you are responding to the right question. Again, you must be able to identify compounds up to 6 carbons. So remember, here in terms of text science, we do up to 6 carbons. So that is from methane, ethane, propane, butane, pentane, and hexane. So you only do 6 carbons. Don't forget that. As this is our revision, I hope you know that by now. And you must be able to write structural formula for given isomers. And you must be able to name the isomers. So when we give you structural formulas, you must be able to say what type of isomers are they. So that is one thing which is important that you have to know. And we are saying you are going to be able to utilize this prefix. Remember, learners, we are saying when we have 1 carbon, it's a meth. When we have 2 carbons, eth, 3 carbons, prop, 4 carbons, but, 5 carbons, pet, and 6 carbon hex. So don't forget, all we are looking for is how many carbons. How many carbons tells us the prefix of that name. Then it becomes easier for us to do the naming of structure. So it's very much important that we know that. So usually I will say map BPH. So that you don't forget. Map BPH there, so showing us the first 6 carbons to say when we have 1 carbon, it's a meth, 2 carbon eth, 3 carbon prop, 4 carbons but, 5 carbons pent, and 6 carbon hex. I hope you got that, and you will be able to apply that when we start with our activities. And as I indicated, that we are going to deal with, hydrocarbons. Hydrocarbons are organic compounds containing only hydrogens and carbon atoms. So you have to look at the name itself to say, okay, these are, remember we're dealing with organic molecules. So you always know that these are organic compounds. So you will say hydrocarbons are organic compounds made up of hydrogens and carbons, but you must say only hydrogens and carbons atoms only. It's made up of hydrogens and carbon atoms only. Please don't forget the word only. If you don't write only, you will omit your marks for that particular simple definition with 2 marks. So now we're saying there are 2 types of hydrocarbons. It's saturated hydrocarbons and unsaturated hydrocarbons. I usually will say, look at the S there as indicating the single covalent bond, because saturated hydrocarbons, they have single covalent bonds between carbon atoms. So they have single covalent bond between carbon atoms. So you can't say they have only single covalent bonds and you don't mention between carbons, because if the double bond must be between carbon, the C double bond O doesn't make the structure unsaturated. So I want you to understand that for us, when you say saturated, we are looking at the 2 carbons. Between 2 carbons, there must be a single bond. Then we say saturated. So saturated means there must be single bonds between carbon atoms. I hope I've emphasized that. Don't forget saturated. Unsaturated, it means now we have a double bond or triple bonds between carbon atoms. So remember, the 3 definitions we have done so far is what is a hydrocarbon, what is saturated, with the S there, remember S for single covalent bonds between carbon atoms. And S, it means now we are replacing the single bonds with what? With a double bond or a triple bond. Hence you will say they have double or triple bonds between carbon atoms. Now, as we move, remember we said there are 4 formulas that you must be able to know. For alkanes, you must be able to know the general formula for alkanes, which in this case is given by CnH2n plus 2. It's very easy for you to remember this if you look at CnH2n plus 2 as being the root where all the other general formulas comes from. So it becomes easier. You will see we're having CnH2n plus 2 here. We're given a structure of propane that I've shown you there. If you look there, you are saying how many carbons? 3 carbons. So 1, 2, 3. Then you go to remember we said map BPH so that we don't forget. Now you know 3 is prop, it's 3 carbons, is prop from what we talked about. So this is propane. So when we are having propane there as a structure, we are saying that CnH2n, you see the prop is coming from the number of carbons, the ane is coming from alkane. So you have to understand that saturated we have alkanes, undersaturated we have alkanes, and for naming we're going to say prop as a prefix. Prop is the number of carbons, how many carbons, tells you how the name will start, which we refer to as a prefix. Ane become the suffix, how will the name end? So every structure that is having carbons and hydrogens only is a hydrocarbon. If between the carbons there are single covalent bonds, so it remains alkane. So remember, we are saying that for alkanes, we will say number of carbons, we get the prop, and then ane is the suffix. So the homologous series gives us the suffix. Now you will see that even with the example of butane there, the same thing. They belong to the same homologous series. Hence, they will have the same general formula, which is CnH2n plus 2. So it's very much important for you to understand that molecules that belong to the same homologous series, they have the same general formula. So as by definition of saying what is a homologous series, we're saying these are series of organic compounds that can be described by the same general formula. So the keyword there is that they have the same general formula. Like I gave you propane and butane. You are able to see that all of them, because all of them they have the same general formula, and each member differs from the next by CH2 group. So if you can see the difference between propane and butane is a CH2. You can see that is 1, 2, 3 carbons. But when you go to butane, you have 1, 2, 3, 4 carbons. So you are able to see that the difference there is a CH2. But all of them, they are alkanes. Why? Because they have single covalent bonds between carbon atoms. So you are able to see that, okay, we're having single covalent bonds between so for us to say this is an alkane, there are two things that we must look at. We are saying there must be single covalent bonds between carbon atoms, and the molecule must be made up of hydrogens and carbons only. Remember, it must first be a hydrocarbon. Then if that hydrocarbon has single bonds between carbon atoms, then we know that hydrocarbon is an alkane. And if it's an alkane, we're going to count the number of carbons. For in case we said, for example, number 1 I gave you there, we're saying 1, 2, 3. So 3 is prop. Then the suffix will come from alkane. Then we put the ane in front of the name. Then it becomes propane. And when we move to alkane, another butane again, you are counting the number of carbons is 4, which is but in accordance to that key that I gave you there. Then but will tell you that we have 4 carbons, and then it's an alkane. Because why alkane? Because there is no double or triple bonds. It's between carbon atoms. It's only single covalent bonds between carbon atoms. So you are able to get that to say this must be butane. Now, for us to move from butane to butene, from an alkane to an alkene, you will see that we are introducing a double bond between carbon atoms. In this case, between carbon number 2 and carbon number 3 now. There's a double bond, as you can see on the structure there. You can see that we have a double bond. Immediately when we introduce a double bond, we remove one hydrogen. But remember, carbon is tetravalent, which means carbon can only form 4 bonds between, 4 bonds around it. So if you bring in a double bond, it means each carbon will have 5, which means we must get rid of two hydrogens from this carbon number 2 and carbon number 3. Hence, you can see there we no longer have hydrogens there. These hydrogens here, they have been removed, because now the general formula will change to CnH2n. You see that we remove 2 hydrogens when we move from alkane to alkene. We remove 2 hydrogens, and when we move from alkene to alkyne, we're going to remove further 2 hydrogens, which will give us CnH2n minus 2. So please remember that the general formula for alkanes is H2n plus 2. For alkenes is CnH2n. For alkynes, you remove further 2 hydrogens, so it becomes CnH2n minus 2. Please remember general formulas. They are very much important. This is your foundation. And then the structure we gave you here, I gave the general formula, and what we have drawn here, we refer to as structural formula. So structural formula, how do you see that this is structural formula? We show all the bonds. Please learners, show all the bonds. When the question says write down structural formula, ensure that all the bonds are shown. So I hope you will do well when it comes to that. And even in terms of naming of alkenes, we are saying you count the number of carbons. So you will say 1, 2, 3, 4. You say these are 4 carbons, and according to our key here is a B, which is a butane, a but. So you will say but there. Then you go and check where do we find the double bond, because it's no longer butane. Remember, it's butane when they are only single covalent bonds. This time we have a double bond, it's no longer a butane. It means now it's a but. In carbon number 2, we have a double bond, so you'll call it but2ene as indicated there. So you are able to name. The same with butane, when we can add another bond there. If we add the third bond there for it to be an alkyne, remember we're moving from alkene to alkyne. We said we will further remove 2 hydrogens. You can see here, these 2 hydrogens, they are no longer there, because now when you form but2 the triple bond, you remove further 2 hydrogens, then the general formula becomes like that. I hope you have enjoyed that first part of our lesson that showed you the difference between the hydrocarbons. To say we have 2 hydrocarbons, 2 types that we are focusing on, the saturated and the unsaturated. And for the saturated, we said they have single covalent bond. The unsaturated, they have a double or a triple covalent bond between carbon atoms. If they have a double bond, we refer to them as alkenes. If they have a triple bond between carbon atoms, we refer to them as alkynes. I hope you have understood that as we move. Now, these structures, they will be straight chains. Some of them will have branches. So you can have, as I gave you the example there of but, you can have 4 carbons, but now you can find that there's a branch there. So once, immediately when you have a branch, it can be, if it was butane, for example, butane, immediately when it has a branch now, you are now going to change the name, because now you have a CH3 here in carbon number 2, in the second carbon there. So it's very much important for you to understand that we refer to these as substituents. So you will call CH3, you can see we have a CH3 there in carbon number 2. We refer to it as a what? As a substituent or as a side chain, or you can refer to it as a branch. So please, if we have a branch, if it's 1 carbon, you will refer to it as methyl. If it's 2 carbons, you will refer to it as ethyl. So you will remember, even when we talk about esters, we refer to this. Even when we talk about branches, when you have hydrocarbons that have branches, you will have methyl, you will have ethyl. So please don't forget that methyl is a methane. Remember, methane is CH4. So when do we have methyl? It's when you have a CH3, as I indicated here. So our methyl means it's a methane that with missing 1 hydrogen. So we have 1 less hydrogen. It's no longer CH4. When it's CH4, it's methane. When it's CH3, running short of 1 hydrogen, is now methyl. So remember how these alkyls are formed. Remember, when you're having C2H6, that will be ethane. However, immediately when you have a C2H5 running short of 1 hydrogen, it's no longer ethane as a branch or as a substituent, is now referred to as ethyl. Please be able to identify these branches. Remember, when you are asking questions on naming, write everything that you know. When you are marking, we'll always look at, if you are able to see the substituent, you will get a mark for identifying the substituent. If you are able to see the parent chain, which is the longest carbon chain, you will still get the mark. So be patient and answer all the questions and ensure that these 75 marks, you collect it. There will be times when you have more than 1 methyl in a structure or more than 2 ethyl in a structure. Then if there are 2, you will say di. If we have 2 methyls, you will say dimethyl. If you have 3, you will say tri. You will see us doing naming of structures, and I hope you have understood that as a whole, to say this is how it goes about. It's important to know that this substituent you must always tell us the number in which carbon do you find them. So you can say this structure, for example, we have 1, 2, 3, 4. 4 carbons. You know the parent chain will be but, and because there is no double bond or triple bond between carbon atoms, it will be an alkane. So the suffix will be A. So butane, you understand. 4 carbons, no double bonds or triple bonds between carbon atoms. Single covalent bonds between atoms are found. So it will be butane. Ane is saying there are only single bonds between carbon atoms. So you'll say butane. And then in carbon number 2, we have a substituent. So you must be able to say 2-methyl butane. I'll be happy if I write everything in small letter. Remember, this is one weight. One weight. You are not separating anything. It's one name weight, and you are able to see there that the two there, and there is a hyphen between the number and the letter M. So always put that hyphen between the number and the letter. Please don't lose these marks. Remember, when we're marking, we'll give you 1 mark for knowing the parent chain is butane, and we'll give you another mark for knowing that in carbon number 2 we have a methyl. I hope you are following and you are enjoying our lesson. But however, the substituent is not only methyl and ethyl. We have another substituent that can be bromo and chloro. Remember, these are the 4 substituents that we do. I'm putting these together so that you understand that the bromo, the chloro, the methyl, the ethyl, they belong to one family of substituent, which means even when they are in a structure, in terms of preference, you are not going to prefer one over the other. They have the same preference. They are all substituent. So you will check which one comes first. The one that comes first, you will give them the lowest number. You will see when you do the naming so that you don't make mistakes when you are naming your structures. So let's move. As we move, remember, I said to you, the first, I said we have 9 homologous series, which is alkanes, alkenes, and alkynes. I refer to them as AAA. I said we have another 4, that is hake, haloalkanes, aldehyde, ketones, and esters. And then I said we have A and C, which is now alcohols and carboxylic acid. So you are able to see that, okay, these are the 9 homologous series that we are having. Of these 9 homologous series, the first 3, we said they are hydrocarbons. They belong to a family called hydrocarbons. Why? Because they are made up of hydrogens and carbons only. So we are fine with hydrocarbons. I hope you have understood them. We talked to their general formula to say for hydrocarbons, the first one is CnH2n plus 2, and the second one is CnH2n. The third one is CnH2n minus 2. We said that is alkane, alkene, and alkyne. So meaning that as we move from alkanes, we remove 2 hydrogens. As we move from alkenes to alkynes, we remove a further 2 hydrogens. So now we are moving to other functional groups. You see the hake, the H there is for haloalkane. Haloalkane, you can see that haloalkanes, as I indicated, we are still an alkane, but in this alkane we have replaced a hydrogen with a halogen. Halogens are group 17 elements. In this case, we focus only on 2, which is bromine and chlorine. So, for example, now we are having an alkane. Let's say we are having an alkane C that we had butane, as I've been using butane throughout for consistency's sake. Let me continue to use butane for you. Now we are saying, let's say you are having a structure here. This structure is referred to as butane. So if you have butane like that, you must be able to know that, okay, for us to get a haloalkane, we are going to put a halo, which is either bromine or chlorine, on the structure. So if we have to remove 1 hydrogen and put bromo there to form 1 bromobutane. I told you that substituents always, when you put them, indicate their number. And between a number, a letter, and a number, there must be a hyphen. So you are saying 1 bromobutane. You see that we have replaced 1 hydrogen in the alkane. So you are able to write the general formula of haloalkanes as CnH2n plus 1x. Remember, it was plus 2. The X stands for the halogen, which is in this case is either bromine or chlorine. I hope you now understand where the 4 general formulas are coming from. Now, from there we move to aldehydes. For aldehydes, we are now going to remove 2 hydrogens. So meaning what that, we'll still have CnH2n and we'll put oxygen there. So meaning that for aldehydes, we're going to have a C double bond O. I will show you now when we go to the next slide to do that. Now, I'm saying from aldehydes, ketones, esters, alcohol, and carboxylic acid. Instead of you writing meth, eth, prop, as we've been doing, you now will write meth. If it's one carbon, you'll write methane as indicated there. Why? You are only going to remove E. Let's say it's an alcohol. It will be methanol. So you only remove the E there. You replace the end of the name with the homologous series. For example, aldehydes, you will simply say, oh, aldehydes, it will be methanol. You see that? So you are able to just do that. So don't forget, because we are still able to, when we go to mark, we still find learners who make mistakes of saying meth, and then they say al, which now is wrong. It must be the whole name. You only remove the E at the end of the name. So this is wrong. The right one, you must write methane. Then from the word aldehyde, the suffix becomes al. So it is methanol. Please don't make those mistakes. Don't lose those marks. Now let's say ketones. If it's this one is still an aldehyde, it will be ethanol. Remember, with the ketones, they start from 3 carbons because the C double bond O is between 2 carbons. So propanone. So you will put the on there. You can even say propan to own, it's fine. Propan to own, propanone. So you're able to see that, oh, propanone means that in the carbon, the second carbon, we have the C double bond O. So it's very much important to know that when it comes to from ake, not from hake, from ake AC, we use the entire name of the alkane. We only remove the E. We replace that E with the homologous series or with a suffix that is from the homologous series. For example, if you are having an ester, you can have, for example, methyl butanoate. Methyl butanoate. Remember, of all the names for esters and carboxylic acid, those are the only two that have 2 names. But the rest of these homologous series, they have 1 name. So when you are naming, you write 1 name. However, when you go to esters, you will write 2 names. Like in this example, I said methyl and butanoate. In the acids, if it's an acid, you'll say pentanoic acid. So you are able to see that these ones, they have 2 names, but all of the others, they have 1 name, and you must write as 1 name. Please, learners, don't make that mistake. The meth, prop, but, pent, and hex, you use that for the hydrocarbons and haloalkanes. But for the remaining 5 homologous series from aldehyde, ketones, esters, alcohol, and carboxylic acid, you write the name of the what of the whole homologous series alkane. You will only remove the E. I hope you got me there. You will see when you do the examples. I've shown you this the functional groups. Remember, you might be asking yourself, what is a functional group? I usually would like a definition that says it's a bond, because you see this bond, they indicate that is a functional group for alkanes, for alkenes, for alkynes. However, our exam guideline starts with the atom. It starts here to say a functional group is an atom. It's an atom. It's a group of atoms. So don't forget, it's an atom. It's a group of atoms that determines the chemistry of organic molecules. So the chemistry, what is the chemistry? It's your physical properties, which you do in question 3, and your chemical properties, which you do in question 4. So that is the chemistry of organic molecules. So they are determined by the functional group. Don't forget, we're saying a functional group is an atom. It's a group of atoms that determines the chemistry of organic molecules. So you are able to see that, okay, these ones, alkanes, alkenes, and alkynes, you see the bonds, single bonds, double bonds, triple bonds between carbon atoms. They tell you about the functional group. However, for haloalkanes, you will look for that X, which stands for bromine or chlorine in this case. Remember, for alcohols, it's a carbon bonded to the OH, which we refer to as a hydroxide group. And it's important that you remember that. Now, we are saying, as we continue, for aldehyde, ketones, carboxylic acid, and esters, all of them, you can see they have something in common. They have a carbonyl, all of them. They have a C double bond O that we refer as a carbonyl group. Now, however, if a carbonyl is followed by a hydrogen, we will call that a formyl group. So you must know that aldehydes, their functional group is called formyl, because sometimes we ask you to write the name of the functional group find in a structure. So you must be able to say, if we give you a structure like that, to say what is the name of the functional group, you must be able to say it's a formyl group. And then the other question we can ask you, we can say, draw the structural formula of the functional group. What is a functional group? Is that which, when you remove from this structure becomes a hydrocarbon. You can see this part. If we cut it here, then we'll remain with a hydrocarbon. We'll remain with only hydrogens and carbon. So it's important for you to understand that for you to identify in a structure a functional group, is that which, when you remove, you will remain with the hydrocarbons. I hope that helps you and it will make you remember that. Now you can see here we have a carbonyl. A carbonyl group is found in ketones there. When you remove this, let me show you here. You can see that we remain with hydrogens and carbons only. So please be able to go to a structure and identify that which is not common within the structure, and that will be able to show you which one is the functional group. In this structure, you can see is for carboxylic acid, we are saying it's a COO. For functional, it's a COO there, it's a COOH. So remember, COOH is for carboxylic acid. For ester, we are saying it's a COO surrounded by carbon. Can be surrounded by a carbon, but this side you can have a hydrogen. Depending on the structure itself, you can have a hydrogen or a carbon this side, but there must be a COO, and then the O must be bonded to another carbon. This O, the single bonded one, it must be bonded to another carbon. Then you know that this is an ester. So this is a functional group of esters. Please, learners, remember all the functional group. Now, how are these esters formed? Esters are formed by a reaction between an alcohol and a carboxylic acid. So when an alcohol and carboxylic acid in the presence of a catalyst, which is sulfuric acid lives where there is water, you will find that the sulfuric acid is a good catalyst to use because it's a dehydrating agent. So because we're going to form water here, we have sulfuric acid that will be able to be there as our catalyst. And then an acid is it is able to donate protons. So in real sense, we are taking the OH from the alcohol and the H from the OH from alcohol and the hydrogen from the acid, and that is able to form water. So please don't forget how to name. When you are naming, the parent chain is the one that is attached to the C double bond O and O. So when you cut your structure, you know that this is our functional group. The one that goes with the C double bond O, the one that has a carbon bonded to the C double bond O, that is the parent structure or the name of the structure. So you can see that in this case we have a methyl, because I told you when it's 4 carbons it's meth. When it's 1 carbon it's meth, and when it's CH4 it's methane. However, when you have methane that is running short of 1 hydrogen, is now referred to as methyl. So you will know that that is a methyl, and we have 2 carbons there. Then we will refer to that as ethanoate. So don't forget, it's methyl ethanoate. So that is our ester. I told you that it has 2 components in its name. They are separated, the methyl and the ethanoate, and water is formed. So don't forget that. And then you must be able, in the exam we can ask you where methyl ethanoate is formed from which organic molecule. So you must be able to say methyl is for the alcohol, so it's methanol, and ethanoate is from the carboxylic acid, so it's ethanoic acid. So you must be able to see that, okay, the parent, where are they coming from? So please remember esterification as a process. However, the main thing we're saying, you must be able to identify and name these esters, where they are coming from. Now, with no wasting of time, the last part of question 2, which is isomers, learners. Remember, we are calling these structural isomers. Structural isomers, we are saying that structural isomers are organic molecules with the same molecular formula. Please, iso means same. So remember that the same thing will always be the same molecular formula. For all of them, the definition just start with the same molecular formula. Please don't get this wrong. When you get a question, what is a chain isomer, what is a positional isomer, what is a functional isomer, you will be able to say they have the same molecular formula. And then what is different, you look at the name. For example, if we say structural isomers, you will say they have the same molecular formula but different structures or different structural formula. So that is how you get it, learner. So that what is same is molecular formula. What is different, look at the name. For example, chain isomers, you will say same molecular formula but different types of chains. So to have different type of chain, meaning that we can have straight chains and we can have branches. One can have more branches, as the number of branches are increasing, but the molecular formula must be the same. Then you know that those are chain isomers. So we're saying same molecular formula, but different types of chains. And then for positional isomers, we're saying it's the same molecular formula, but different. I usually will say here for positional, different SSF. Don't forget, it can be different substituent, different side chain, different position of the substituent, of the side chain, or of the functional group. So there are three things that are different in that case. So remember, functional isomers, we're saying same molecular formula but different functional group. I gave you examples here for you not to forget. Remember, butane, it has how do I know that butane and 2-methyl propane are isomers? What I will do, I will look at the number of carbons to say this is having 1, 2, 3, 4. Then I will write C4, and then how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You count them. C4H10. You go to the next structure. When you count the number of carbons, they will be C4H10. So you're able to say they have the same molecular formula. So please count them during the exam. When you're writing, count the number of carbons, count the number of hydrogens, and they will tell you whether they have the same molecular formula. If they have the same molecular formula, you'll be able to say what is different. You say these are different types of chain. The other one is a straight chain, the other one is a branch. So you say these are chain isomers. The same when you are given the chlorine, you can see that chlorine is in carbon number 1 in the positional isomer and chlorine in position number 2. Remember, what did we say? What is the same molecular formula? If you check all of them, you have 3 carbons, it's a C3. You count the number of hydrogens around, which is 1, 2, 3, 4, 5, 7. So that is C3H7Cl. If you do here, it will give you the same C3H7Cl. So you'll be able to say same molecular formula. But what is different is the position of the substituents. Remember, I said chloro and bromo, methyl and ethyl, they are substituents. So you say, oh, different position of the substituent. So the substituent is in carbon number 1, the substituent in carbon number 2. So this must be a positional isomer. Now you are able to move as well to say, okay, now we have the functional isomer. For functional isomers, you will have seen that I usually will say cake there. To say cake, we are saying, remember, carboxylic acid and esters. So when you see carboxylic acid, they have 2 oxygens and esters have 2 oxygens, and then you know that those are functional isomers. It means that they have the same molecular formula, but they have different functional groups, which means they belong to different homologous series. So for aldehyde, it goes with ketone. So please don't forget that if you see a carboxylic acid, we say what is the functional isomer. You must be able to remember that for carboxylic acid, it must be an ester. For aldehydes, it must be a ketone. You have seen when you're doing the general formulas, they still have the same general formula as well. I hope you will do well when it comes to this aspect. I just wanted to show you the same thing. So it's the same thing I was explaining in the previous slide. So I won't waste your time. I know, guys, you really want to collect as many marks as possible tomorrow. So we must be able to move. Positional isomers as well. At least on the first example, I used the chloro. It was in carbon number 1 and carbon number 2. In this case, it is what? It is the double bond. The alkenes, we're having an alkene. Then you can see that this one now is but 1-ene. Why but? Because we first number the number of carbons. 4 carbons we said is but. In carbon number 1, we have a double bond. So it's but 1-ene. On the other structure, it's still 4 carbons. So it's but 2-ene. So you can see that what is changing is the position of the of the double bond, which is the functional group. So it's always important. If you name your ester, the names will tell you what is different between them. Then you will be able to know. I mean, if you name your isomers, the name will tell you the difference between the two. In this case, you can see it's a 1 here and a 2. So you are able to see that the difference is the position of the double bond, which is that makes the structure an alkene. I hope that helps you. The functional isomers, I talked about that. So with no waste of your precious time, let's do an activity. I've been talking. Now let's look at an activity to say, this is a question. Multiple choice questions, learners, please. You are given 4 options. We're saying of the 4, 2 are disruptors. They're just there to disrupt you. They are not answers. So please ensure that you remove the disruptors first. Now, this question says, to which homologous series does the molecule C8H14 belong? The first thing, as a technical science learner, you will say, C8H14, alcohols have oxygen. There is no oxygen here. That already tells you that this one is out. It can't be part of that. Now, you go back, you say, okay, according to, for alkanes, we said the general formula is CnH2n plus 2. So you're able to say, okay, if N is 8, remember N stands for the number of hydrogens. If N is 8, it means it will be C8. 2 times 8 is 16. 16 plus 2, it will be 18. So if it was an alkane, it will have been C8H18. If it's an alkene, you will say CnH2n. So you would have said C8, 2 times 8 is 16. So 2C8H16. You are able to see it's not that one. How? Definitely, when we move from an alkene to an alkyne, we remove further 2 hydrogens, which means this is going to be C8H14. So you are able to choose your answer. When you leave exam room, you are sure that C is the correct answer. Remember, you're going to write 1,1 is C. Learners, no matter what, ensure that you allocate enough time for multiple choice questions, and ensure that you don't leave a multiple choice question unanswered. Remember, there will be times when you don't know really what the answer is, or you think, but there will be an answer that you think is closer. Just write that one. Don't leave a multiple choice question unanswered because you are losing marks. Please, we're just pleading with you. The general formula of haloalkanes, we have done this one to say it's an alkane, but we are removing 1 hydrogen, so that will be T. So you're able to get 1.2, then you write T. I hope you will collect as many marks as you can tomorrow when it comes to multiple choice type of equation. Now, as we move now to question 2. Remember question 2, this was taken from 2020 paper, just for us to be able to revise. Please, learners, don't be in a hurry to answer questions. Understand the question first. Look at this. It's saying organic molecules can be classified into different homologous series that are identified by their functional group. Define the term functional group. You will remember what I told you what a functional group. I said that functional group, when you look at the structure, you are saying this is what makes this different from hydrocarbon. This is what makes this different from other functional group. This. So you are able to see that, okay, a functional group is what? It's an atom. We talked about that to say it's an atom. It's a group of atoms. Group of atoms. So you're able to answer that question. We said that determines the chemistry of an organic molecule. Please write that. It's an atom. It's a group of atoms that determines the chemistry of an organic molecule. Now, if you look here, I've written F.H. Jameson. I'm saying these are the questions that we are going to ask you in the exam to say, what is the functional group? What is the functional group? That is the question they will ask. You will see that the functional group there is a C double bond C. So the first thing you must ask yourself, what is the functional group? The second question, the H there, is for saying what is the homologous series. You know that these are alkenes. So you must know that what it is that. And then the general formula for alkenes, you must know is CnH2n, because we said from alkenes, we remove 2 hydrogens. So it's CnH2n. Now, when you move from there, we are saying the the M there is for molecular mass. To say for carbon is 4 carbon. Remember, you are substituting the CnH2n. So from general formula, when you substitute N, you will get molecular formula. So be careful of that to say, okay, it's a boot, it's 4 carbons. So it means it's a C4H. 2 times 4 is 8. So you get C4H8. We refer to that as general formula. Molecular formula, M stands for molecular formula. We're saying for, S stands for structural formula. For structural formula, we're saying you must show all the bonds, which means you will draw 4 carbons, showing all the bonds, and you will draw around them, there must be 8 hydrogens. And we're saying in carbon number 2, there must be a double bond. So you will put first the double bond in carbon number 2. Then you will put the hydrogens. Remember, each carbon must have a maximum of 4 bonds around it. You can't have a carbon which has more than 4 bonds around it. Please, always when you're drawing structural formula, count the number of bonds around a carbon so that you don't lose marks unnecessarily. Now, as we move, you see you were able to draw the molecular formula, general formula, molecular formula, structural formula, and then condensed. You know, condensed is not a difficult. You are simply saying carbon number 1 is a CH3. Carbon number 2 is a CH. Carbon number 3 is another CH. Carbon number 3 is a CH3. So that becomes our condensed structure. So you're just saying on this carbon, how many hydrogens, how many atoms for each carbon. Then you write them in a condensed way. Hence, we have the condensed structural formula. And then the I stand for the name, which in this case was given as but2-in, and the N, the I stand for the isomer, to say but2-in. Does it have isomers? Definitely. If it's the double bond is in carbon number 2, there will be but1-in. So you are able to say, okay, it has an isomer which is but1-in. What type of an isomer is but1-in compared to but2-in? They are positional isomers, because the double bond is in carbon number 1 in but1-in, in but2-in, the double bond is in carbon number 2. So I hope you are able to follow. And the last is the name of the structure. Those are the questions that we will be asking you. So practice, when you get a question, use the FH Jemsin and check what is the functional group, what is the homologous series, what is the general formula, what is the molecular formula, what is the structural formula, and then what is the condensed structural formula, what are the isomers, and then what is the name. If you ask yourself those questions for every structure, as you are, every table that you are getting as you are revising, and you do this, I'm telling you, you will be very confident. Come tomorrow, you will do very well. Come final year, you will be laughing in the exam because you will be doing a lot better. Now, that is the strategy that we're going to use. There are many questions that can be asked for you to answer. And I know that you will enjoy yourself, because as you are using that strategy of FH Jemsin, you are able to answer all the questions that will be asked. Now, the next question, which in this case is question 3, is for physical properties. Now, for physical properties, we are going to focus here. I want to go straight into it. 4 definitions, which is the melting point, boiling point, vapor pressure, and viscosity. So we have 4 definitions that, please, you must know. Definitely you will get one of these definitions come the paper, or 2. I don't know, I didn't see it, but I'm saying we have no way. We have to ask you definition questions, and we'll ask you definition questions, and it's important. So you can't wake up tomorrow and say you are going to write an exam, but you don't know the definitions. Please know the definitions. What is melting point? So we're saying melting point is not a point, learners. Please, it's not a point. Remember, you're saying melting point of water is 0. Melting point of boiling point of water is 100. Is 100 a point? No, 100 degrees Celsius. It's a temperature. So you must know that melting point is a temperature. So it's a temperature at which the solid phase and the liquid phase are at equilibrium. The solid phase and the liquid phase are at equilibrium. Please remember these definitions. Boiling point, we're saying vapor pressure is the temperature. Always start by saying it's a temperature, and then at which the vapor pressure is equals to the atmospheric pressure. You write it in full. It's a temperature at which the vapor pressure is equal to the atmospheric pressure. What is the vapor pressure? You are saying this is a pressure exerted by vapor. Pressure exerted. So vapor pressure, when you answer, you're saying pressure exerted by vapor, and then at equilibrium with the liquid, at equilibrium with its liquid in a closed system. So when you're defining vapor pressure, you will ensure that you name it, that this is happening in a closed system. Then we have our last definition for this question of physical properties, which is viscosity, and we're saying is the property of fluid to oppose relative motion between two adjacent layers. So you're having two adjacent layers, then that property of the fluid to oppose motion, to say you can't go anywhere. So that is viscosity. It's the property of the fluid to oppose relative motion between two adjacent layers. Please, I'm just pleading with you, remember these definitions. You will get your marks. Now, as I indicated when we started with the lesson, that we are dealing with 9 homologous series, which is AAA, Hague, AC. Please don't forget them. Please remember them all the time. The first A is for aldehyde. The second one is, the first A is for alkanes. The second one, alkene. The third one, alkyne, haloalkane, aldehyde, ketones, esters, alcohol, and carboxylic acid. And the way we have organized them, it works for us when it comes to physical properties. When it comes to these physical properties, it works for us now because we are able to say AAA, which are hydrocarbons, which are saturated and unsaturated, which is alkane, alkene, and alkyne. They have London forces. So you know that London forces, because the first mark will ask you to identify the type of the intermolecular force. So if it's an alkane, it's an alkene, it's an alkyne, you must know that this has London force. And then you have the haloalkane, the aldehyde, the ketones, and the esters. Those ones, they have London forces as well as dipole. Hence, they are stronger than London forces, because the dipole are much stronger than London forces. So we have two forces on the Hague, and then on the alcohols and carboxylic acid, we have the London force, the dipole, and the hydrogen bond. But for differentiation, we will refer to the hydrogen bond, but you know that even the London forces we have there, and the dipole. So you have to know that London force, dipole, hydrogen bond. So if you can focus on those for now, to say we have London forces on the alkanes, alkenes, and alkynes. Haloalkanes, aldehyde, ketones, and esters, they have London force and dipole. However, we'll refer to the force that is having more strength, or the one that makes them, that brings about the difference between Hague and AAA, which is dipole. So we're saying this is the weakest, and we're saying dipole is stronger than London force, but weaker. And I've indicated all these notes here on this slide to say we have London force, we have dipole, we have hydrogen bond. So please know that AAA is London force. Hague, which I've indicated there, that is your dipole. Alcohols, they have only one oxygen, OH. They have only one OH, which is one side of hydrogen bond. However, carboxylic acid, it has two oxygens, which serves now as sites of hydrogen bond. So carboxylic acid has two sides. So carboxylic acid is the strongest intermolecular force as compared to these others, because it has two sides of hydrogen bond, as compared to alcohol that has one side. Remember, we're saying alcohol and carboxylic acid, all of them, they have hydrogen bond. However, carboxylic acid have two sides. So carboxylic acid are stronger than alcohols, because sometimes we'll give you an alcohol and a carboxylic acid. Always refer to the strength, as I was doing. So you will identify, we say ice here, ice, because you will identify the type of the force, which is either London, dipole, or hydrogen bond. Immediately after identifying it, you compare the strength. The C is for compare strength. Please, learners, when you're comparing the strength of intermolecular force, ensure that you talk to the given organic molecules, and from there you compare the energy required to overcome the intermolecular force. So when you talk about energy, you say the amount of energy required to overcome the intermolecular force. You will refer to it as such, as the energy required to overcome the intermolecular force. So please ensure that you do like that. Here we just wanted you to see London force. They are the weakest. You can see the bond there between those hydrogens. And then you have the dipole, we indicated all those structures. And then the one side of hydrogen bond alcohol, they have only one OH. So you see they have one side of hydrogen bond. But if we look at carboxylic acid, they have an OH and an O there. So this is a site for the first hydrogen bond. This is a site for another hydrogen bond. That's why we're saying they have two sides of hydrogen bonds, which makes them much stronger than compared to the other. So that is hydrogen bond. And Lenas, I want to say this question on physical properties is an investigation type of equation. So you have to know the variables to say what are the dependent variables. Remember, dependent variable is what we are measuring. What we measure is our dependent variable. Independent is what we are changing. What are we changing? Always ask yourself that question when you start with the question to say, what are we measuring here? What are we changing here? And how the relationship between the dependent and the independent, because they are going to help you when you say formulate an investigative question. You're going to use the dependent and variable. You're going to ask a question on the relationship between the dependent and independent variable. Please let us do that. And remember, in this section, our dependent variable, we only measure 4 things, which is the melting point, boiling point, vapor pressure, and viscosity. So if you find a question that is asking about dependent, you will look on the table there to say, what are we given? If you are given a melting point, you will say melting point. If you are given boiling point, in that order. Now, independent is what we're changing. During the experiment, what do we change? We change, I always want to refer to it as if chain mob, so that you don't forget that what do we change? We can change the type of intermolecular force. We can change the functional group. We can change the chain length. Some shorter chain length, longer chain length. So you always check what is changing on the table. So when you get a table, you're going to look for these 2 things. Dependent variable and independent. Sometimes we ask you this question in a graph form. So when you get a graph, you know on your y-axis, you will be having your dependent variable, and your independent variable, what we are changing, will be on the x-axis. Please, learners, don't lose these marks. They are there for your take. So we're saying the independent variable, there are 5. It's intermolecular force, functional group, chain length, molecular mass, or branch. Sometimes we just give you 0 branch, 1 branch. If the structure has no branch, the other one has a branch. You know, as the number of branches increases, we are saying the strength of intermolecular force will decrease. So please make sure that you do well in terms of that. I indicated that the type of question can be in a graph form. So don't be amazed. You can get a question like that, but you have to know number of carbons. Number of carbons is a chain length. Remember, I've said if chain mob. So you know that this here, you'll have your independent variable, and then there you will have your dependent variable. Please, if you get a graph type of equation and it's asking you about dependent and independent, just collect the marks and enjoy yourself. Now, know that the independent here is the chain length, which is the number of carbons, and the dependent, which is on the y-axis, is your boiling point, meaning that we are measuring the boiling point, and you can see what happens as the number of carbon increases. You can see what is happening to the boiling point. I think you are able to see that it increases as well. So with no wasting of time, some of the questions, you will get them in a table form. So you are expecting a graph type of equation or a table type of question. So if it's in a table form, you are able to say, okay, this is the table that we are given. What is changing here? You are having 1, 2, 3, 4, 5 carbons. Now you have a branch here. Now you have 2 branches. So you're able to say, 0 branch, 1 branch, 2 branches. So you're able to say, okay, what is changing now is the number of branches. So that is your independent variable. What we are changing is the independent variable. What we are measuring is your dependent variable. Please, learners, don't forget that. And you can see that as the number of branches increases, the vapor pressure is increasing from 450, 592, 1102 kilopascal. So you are able to see that, okay, as the number of branch increase, the strength of intermolecular force decrease. Remember that. As the number of branch increase, the strength of intermolecular force decrease. As the strength of intermolecular force decrease, vapor pressure increases. So you have to know boiling point, melting point, viscosity. As they increase, even the strength of intermolecular force increase. Boiling point, melting point, viscosity, they increase with increase in the strength of intermolecular force. However, vapor pressure decrease with increase in strength. When you see the strength increasing, vapor pressure will decrease. When you see the strength decreasing, like in this case, you can see that as we are moving from 0 branch, 1 branch, 2 branch, the strength of intermolecular force is decreasing. As the strength of intermolecular force decreases, then the vapor pressure increases. Please, learners, I hope you will get that come your writing exam time. Now, all that I was explaining, summarizing this slide to say, please remember, boiling point increases with increasing the strength of intermolecular force, and boiling point decreases with decreasing the strength of intermolecular force. Melting point as well, it increases with the increase in the strength of intermolecular force. Viscosity as well, it increases with the increase in the strength. However, vapor pressure, it increases with the decrease in the strength, as we have seen in the previous question that we're talking about. Please ensure that you are aware of that and you are able to do that. Let's look at a question as we are moving. So you are able to check here to say, okay, what is my dependent? Remember, we said dependent is always these ones that we are measuring, dependent. So it's vapor pressure in this case, which means independent is the molar mass. What happens as the molar mass increase? You can see what happened to the strength of intermolecular force. As the molar mass increase, the strength of the intermolecular force increase. So you can see the strength of the intermolecular force increase. As the strength of intermolecular force increase, vapor pressure decrease. Remember the other three: viscosity, melting point, boiling point. They increase with increase in the strength of intermolecular force. So you can see as the molar mass increases, vapor pressure decreases. So we'll say explain the trends between that. You must be able to answer that. Now I want to look at question 3.2.2, which says explain the answer to question 3.2.1. Remember 3.2.1 is saying describe the trend in vapor pressure of the compounds above. So you will be able to say, okay, when I describe, I'm going to say as molar mass. So as molar mass increase, vapor pressure decrease. You'll write in words: molar mass increase, vapor pressure decrease. This is what you are saying. You're just writing your observation as you look on the table. Now, then we are saying in question 3.2.2, explain why when molar mass increase, vapor pressure increase, by referring to the chain length or molar mass, strength of intermolecular forces, and energy. So you are going to now to be able to say, okay, as the molar mass increase, the strength of intermolecular force, you must not write in short IMF, just write intermolecular force in full. The strength of intermolecular force increases. So as the molar mass increases, the strength of intermolecular force increases. As the strength of intermolecular force increases, when the strength of intermolecular force increases, more energy. So more energy is required. Remember, energy is required to overcome the intermolecular force. So when the strength increases, you will need more energy to overcome those intermolecular forces. When the strength decreases, you will need less energy. In this case, the more energy is required to overcome the intermolecular force. We are saying on this one, learners, please write in bullet form. As I indicated, is ice. The I is your independent variable. In this case, is your molar mass. So you will say, okay, you identify. You are saying, okay, my independent variable is a molar mass. That's what is changing here. So you are saying molar mass. As molar mass increase, vapor pressure decrease. So you can see what is changing here is the molar mass. As the molar mass increase, the vapor pressure increase. Then you go to the strength of intermolecular force to say the strength. What happened to the strength? You compare. You say, okay, as the molar mass increase, the strength of intermolecular force increases as well. So as the strength increases, more energy. Then we are able to give you your 3 marks. Hence, we are saying the vapor pressure will decrease. I hope I've stayed there and you have heard, and you will write in a point form. Ice was saying you will identify your type of intermolecular force that is involved, or you will identify your independent variable. Then you will compare the strength of the intermolecular force, and then you will compare the energy required to overcome the intermolecular force. Please, learners, write in bullet form. You will collect all your marks. Now, we move to reactions. I will try to be fast so that we are able to cover everything we need to cover. Reactions of organic molecular compounds, learners. Here, remember, we're doing with us, we're doing addition, we're doing substitution, we're doing combustion. So those are the reactions that you are doing. So under addition, we're doing addition polymerization as well, where we're forming polymers. But in this case, look at addition, for example. We are saying USA. USA, we're saying when you have an unsaturated, learners, please just listen to me on this one to say, when you see a double bond, you know the reaction that it will undergo must be addition. So on that one, you see a double bond, the type of reaction, you know it must be addition. So we say USA, meaning that when an unsaturated becomes saturated, the type of reaction is addition. So you won't forget that. And now it depends on what we are adding. If we are adding hydrogens, the reaction will be called hydrogenation. If we are adding hydrogen, the reaction will be called hydrogenation. Remember, we always add on the double bond. Where there is a double bond, we're going to add hydrogens there. When you add double bonds, there will be no double bonds any longer. Immediately when you add the hydrogens in the double bond, there will be no double bond any longer. So please know that. If you are adding water, it's very much important. Remember, water is H and OH, learners. Please, the hydrogen must go where there are many hydrogens. The hydrogen must come here. The hydrogen goes where there are many hydrogens. Listen to that one. And then the OH will go where there are lesser number of hydrogens. Please, the bond between O and H must be shown if you are drawing structural formula. So we're saying hydrogen goes where there are many hydrogens, and OH will go to another carbon. And then we no longer have a double bond when we add water there. Please don't forget that. Then we'll refer to that as hydration. Hydration, because we're adding water in our double bond. When it's chlorination or when it's halogenation, you will add Cl2. It means on each carbon, you will add chlorine there, and then the double bond will be broken. Now, hydrohalogenation, it means you are adding a hydrogen and a chlorine. Please ensure for the major product, because we form two products. One is called major product, the other one is called minor product. For the major product, ensure that the hydrogen goes where there are many hydrogens. So the hydrogen will come here, the chlorine will go where there are lesser number of hydrogen, meaning that the chlorine will come there. Please don't forget, hydrogen will always go where there are many hydrogens, and then the other molecule will go to the other carbon. And then the reaction conditions, learners, you have to know the reaction condition. As I told you, when you see water, you think about sulfuric acid, because I said it's a dehydrating agent. Please remember, when it's water that is being added, the catalyst will be sulfuric acid, H2SO4. When it's hydrogenation, the reaction condition, catalyst, platinum, palladium, or nickel. So those are the for bromination or chlorination, or when we are doing halogenation, you don't have to worry about the reaction condition. Hydrohalogenation, just ensure that there is no water that is present. Please don't forget, we are saying USA for this one. When you see a double bond, you know any R that comes from that double bond, it must be addition kind of reaction. Please, learners, get this one correct and collect marks. Don't forget reaction condition. Know them. You must be singing all these reaction conditions as you do questions. The other type of reactions that we do is what we refer to as here as substitution. Now, for substitution, we are saying saturated remains saturated. So you have a saturated here forming another saturated. Saturated, we said there is no double bond between carbon atoms, and you can see, or triple bonds. So there is no double bond, is saturated. So this is saturated. Immediately when it forms another saturated, you know that is triple S, is substitution. Please, learners, collect your marks. You're just looking at that. And then what type of substitution? You check what you are using to substitute. For example, if you are using halogens, you will call it halogenation because we are using a halogen to substitute. If now, for example, you are having a haloalkane, which is in this case 2-bromobutane, if you can add water, that reaction with water and mild heat. Remember, our heat must be mild heat. If you use you add water there, then you are going to form an alcohol. And then if you can even use dilute, it must be dilute sodium hydroxide. So you must know that there are two types of hydrolysis, which you can use water, you can use sodium hydroxide. And then we are saying now as well, you are able to form your alcohols. And if we bring another HBr there, we can be able to substitute the OH with the Br. As you can see there, then we call it halogenation as well. Don't forget, reaction condition, we're saying mild heat. For hydrolysis, we're saying there are two hydrolysis, the one we're using water and the one that we're using dilute sodium hydroxide or dilute lithium hydroxide, dilute potassium hydroxide. That's the group 1 elements and their hydroxides. We use them there. So I hope you have understood that and you have seen that for substitution reaction, you will always see single bonds remaining single bonds. Then we don't have problems. And then we don't have double bonds here involved. When we have double bonds involved, you will know that we are dealing with that. Now, let's look at plastics and polymers, which is the last part of your organic chemistry. Please remember the definitions of what is a macromolecule, what is a polymer, what is a monomer, and what is polymerization. And then you have to know that plastics or synthetic materials are derived from organic compounds. And we are saying you must be able to identify monomers from given addition polymers. So you can be given a long structure, then you must be able to identify the polymers which were used. Lastly, you must know the uses of polyethylene. What do we use this polyethylene for? So those are the things that you will focus on when you are dealing with that. As I indicated, for polyethylene, we're saying is many ethene. Remember a monomer which is ethene, the C double bond, this is our monomer, our ethene, and then is reacting with another ethene, and it's many of them. Hence now, these monomers, they form a polymer when they are joined together, and the reaction is called addition polymerization. It's an addition because we have the double bonds, don't forget. So this is addition polymerization. They are able to form that one. So we can give you this long structure like that to say identify the monomer. So you must be able to know that the monomer is ethene. Hence we call it poly. Poly means many what? Many ethenes. I hope you got that. And then with no waste of time, we'll go and look at the uses of polyethylene. To say polyethylene is used for squeeze bottles, for plastic bags, films, toys, and molded objects. And it has a recycling number of 4. So I will leave it at that as far as organic is concerned. And then if we are to look at that, we are able to say this is unsaturated forming saturated. So the reaction will be addition. Please don't lose that. This is unsaturated forming saturated. The reaction will be addition. So that's what you must be doing during the exam. This is saturated forming saturated. The reaction must be substitution. What is left is for you to say what type of substitution, what type of addition. I hope that will help you as we move. I just want now to introduce this one, which is our last topic, electrochemistry. To say, please learners, on this one, you have done this in grade 10, grade 11. We're saying that these are metals. And metals, they have electrons that are loosely bound. So these electrons are loosely bound. They easily lose electrons. So under normal circumstances in grade 10, grade 11, you were learning that these metals will lose electrons. The non-metals this side will gain electrons. So that's what we're going to talk to even on this section. To say, as we move, this is what we have done in grade 11. In grade 11, you have done redox reactions. You have done what is oxidation. We're saying oxidation is loss of electron. Please don't forget Leo. We're saying loss of electron is oxidation. And reduction. For reduction, we're saying gaining of electrons is reduction. So remember that Leo, the German, Leoga. So say Leo is loss of electron, is oxidation. Gaining of electrons is reduction. And then you must be able to know what is the anode, what is the cathode, and then you are saying the anode is the electrode. Electrode where oxidation occurs. NOx. If you want to remember, you just say NOx. NOx, you are saying an anode is the electrode. From the word ode there is the electrode where oxidation occurs. NOx, for you not to forget. For the cathode, we are saying is an electrode. Please don't forget, it's an electrode where reduction takes place or reduction occur. So red cat. So we're saying it's an ox, and red cat. Don't forget, red cat is a cathode, is an electrode where reduction takes place. Anode is the electrode where oxidation takes place. And then remember, you have done oxidation numbers. Now, on this one, we're going to do electrolysis, which will be electrolysis of copper chloride. So copper chloride solution is CuCl2. So you have to know that is the electrolysis that you have done in grade 11 and you are still doing in grade 12. And you are hoping that tomorrow you will get a question on that or on electroplating. I've done this. I've done the definitions with yourself to say I indicated loss of electron is oxidation, which is Leo, and then Ra is the reducing agent, is oxidized. So you have to know that the reducing agent is a substance that undergoes oxidation. Reducing agent. So from here, you know that reducing agent is a what? It's a substance that undergoes oxidation. And we are saying Keroa, we are saying gaining of electrons is reduction, as I indicated, and we are saying that is the oxidizing agent, and the oxidizing agent is reduced. So you are able to do that. And then we are saying oxidizing agent is a substance that undergoes reduction. The anode, we talked about that, to say is the electrode where oxidation takes place. The cathode is the electrode where reduction takes place. Please let us revise this as much as you can, and you will collect many marks. Now, the first cell that we are talking to is what you refer to as galvanic cell. So the galvanic cell, the first thing you must know is the definition, which is energy conversion, to say it converts chemical energy to electrical energy. Please don't forget, galvanic cell or voltaic cell, it converts chemical energy to electrical energy. And this reaction is spontaneous, which means no power source that is needed, no DC power source that we use here. It is self-sufficient. It doesn't need energy to be added. In fact, it releases energy. Hence, I said it's exothermic. So it's important that you know that galvanic cell it converts chemical energy. You can't go to write without knowing that the definition that galvanic cell converts chemical energy to electrical energy, and it is spontaneous. And we're saying this one, generally it has two separate different metals that are immersed in separate beakers. So you have two beakers, and inside the beakers you have the metals that are immersed there and containing the metal ions. If you have a metal, it will be in a metal ion, and there will be a salt bridge, as will be indicated in the example we're going to use, which is the zinc copper cell. And if you can check, many times we are asking questions on these zinc copper cells. So I think even before you sleep, you will make sure that you have revised the zinc copper cell, you understand it. Remember, when you look at on the table, you will see that in table 4b, which I will use for this example, you will see that zinc comes before copper. You will find that when you go to the table, you are given zinc 2+ plus 2 electrons, forming zinc, and then with the standard electrode potential of negative 0.76, and then you are given copper 2+ plus 2 electrons, forming copper with the electrode standard potential of positive 0.34. It's important. I will have preferred that when you copy this and the numbers, so that you don't have to go back to the table again. Remember, immediately when you see that this question is about zinc and copper, you go to table 4b for galvanic cell. For this, for you to understand the method I'm using, 4b, you go, you choose them, you write them down as I've written them down like that. You're saying, okay, zinc, the first one, the negative one, must be reversed. The first one must reverse. So it means when you write the half reactions, remember, now you're going to write oxidation half reaction and reduction half reaction. So the first one, you will reverse it. You will start it from zinc. You will say zinc forms zinc 2+ plus 2 electrons. You see, you are writing it from backward. Always, you are using table 4b. The first one there, the top of the table, you reverse it, the negative one. Your reducing agent. That is your reducing agent. The more negative one is your reducing agent, and it must be reversed. So you reverse it, you write that in reverse. The more positive one is your oxidizing agent, so it must be written like that. So you will write it as is. You see now when I'm writing the half fractions, I'm no longer using double arrow, I'm using only one arrow. So please don't forget. I'm saying the most negative one is your reducing agent, it must be reversed. The more positive one is your oxidizing agent, you must write it as is. But now when you write the half fractions, they must be inward, they must be having one arrow. So the first one, we call it loss of electron, which is oxidation, which means zinc is our reducing agent and is oxidized. The second one, we call it gaining of electrons, and we refer to that as reduction. It is the oxidizing agent and is reduced. And you can see when you look that copper 2 plus is gaining electrons, is true, and is undergoing reduction because it's starting at copper 2 plus, but now is 0 yet, there is nothing there. So that's why we say is gaining of electrons, is reduction. Then copper 2 plus, remember your reducing agent and your oxidizing agent are on the left of your half reactions. So copper 2 plus is your oxidizing agent, not copper. Copper 2 plus is your oxidizing agent. So when you say which one is the oxidizing agent, you go to the half reactions. You know that oxidizing agent is this copper 2 plus. Zinc would be your reducing agent. The more negative one is your reducing agent. The more positive one is your oxidizing agent. Yes, we are doing well. Now, from there, learners, please just make a line. Immediately when you write the half fractions, balance the electrons. Ensure that the electrons are balanced. You can see for the zinc 2 plus, we have 2 electrons. For the copper 2 plus, we have 2 electrons as well. So you can simply now cancel the electrons. You don't cancel the electrons until they are balanced. Ensure that the electrons are balanced. Then you can cancel them. Then what is on the left? You write on the left. You see on the left here, we're having zinc plus copper 2 plus, they are forming zinc 2 plus copper. So you are able to see this is your overall cell reaction. You are getting 3 marks for that, for writing the overall cell. How to write overall cell reaction or net cell reaction? I'm saying the simplest thing to do. You go to the table, you copy the two substances that you are given. In this case is zinc and copper 2 plus, is zinc and copper. You copy them the way they are written on the table. The first one, the most negative one, which is the reducing agent, you reverse it. You write it in a reverse. The more positive one, you write it as is, but now writing one arrow that you are using. And then we are saying that the first one, where you have your reducing agent, that is your oxidation. It's a loss of electron, it's oxidation, which is your reducing agent, because we said a reducing agent is a substance that undergoes oxidation. Please, once you do that, write what is, once you do that, you cancel the electrons. What is on the left, you write on the left. What is on the right, you write on the right. And remember, because zinc is losing electrons, obviously it must decrease in mass. And because copper here is gaining electrons, it must increase in mass. It's important for you to note that. Now, the next thing which is important, we say here A, B, C. Remember, as you are doing your reducing agent, that is your loss of electron, which is oxidation, which is your reducing agent, is your anode, and then you have your oxidizing agent as your cathode. So the one that is the smallest one, which is your anode, which is the negative one, is your anode. The positive one is your cathode. That is applying to galvanic cell. So you know that, okay, we're having the anode and the cathode. So you say ABC here when you write cell notation. So cell notation, you're going to utilize ABC. So you're going to say anode, which is zinc, forming zinc 2 plus. And then you have the bridge in between. So you will write the double arrow there for the salt bridge. The B stands for the bridge. A is for the anode. In the anode, we have zinc becoming zinc 2 plus. In the cathode, we have copper 2 plus becoming copper. So you write copper 2 plus becoming copper. Please, learners, remember, this is 3 marks as well. Please don't forget. You always start with the anode and the salt bridge. We can ask you, what are the functions of the salt bridge? So you must be able to know that the salt bridge, it maintains electrical neutrality. It maintains electrical neutrality by allowing the movement of ions. It allows the ions to move here in the salt bridge. You can see K plus, the cation goes to the cathode, N ion goes to the anode. Don't forget, N ion to the anode, cation to the cathode. N ion is the negative one. It goes to the anode. The positive one goes to the cathode. I hope You have understood that, and then those are the most important thing, which is the overall cell reaction and the cell notation. Please, learners, make sure that you get it and you get it correct. I said this one will decrease in mass, this one will increase in mass. As that happens, the solution will increase. Where there is decrease in mass, the solution of the electrolyte increase, and then when on the other side, it will decrease. I hope as and when you come across this type of questions, because we can even say calculate EMF of the cell. So when you say calculate EMF of a cell, you'll say E of a cell is E cathode. Learners, we are saying to you here, please copy the formula from the data sheet. Don't write the formula that you understand. Just write the one that is given for you for free in the data sheet. Go to the data sheet and copy the formula correctly. Cathode is that bigger one, which was 0.34 minus 0.76. That will give you 1.1 volt. We say spontaneous is positive. So sometimes you can say, show that this cell is a spontaneous cell. So you know that you are calculating EMF. I hope you got that and it will help you. This is what I referred to. I told you that as the anode loses electrons, zinc is losing electrons, you can see it decrease in mass. But copper 2+ is gaining electrons, then it does what? It increase in mass. So I've indicated that to yourself when I was demonstrating that. And the salt bridge shown you there must always be solids here outside. If there is no solid, you must use the carbon as the solid. So those are our solid. They must be outside of the cell notation. We talked about that. And then I indicated that you are using a table. You go to the table. If you go to the data sheet, you will find those three formulas. Please just choose one, and then you always start with the bigger one minus the smaller one, which is the cathode minus the anode. Then you get your answer as I indicated in my previous slide. The table, this table, we have table 4A and table 4B. You can use this table to identify the oxidizing and reducing agents. You can use it to identify the anode and the cathode. I told you already that your reducing agent is where the anode is the smallest one, and then you can even use it to write balance equations. You can use it to predict whether the reaction is spontaneous or not. So there are many uses that you can use table 4A and 4B, and I will prefer, for the sake of what we discussed, for you to utilize table 4B. The questions, the zinc half cell, it was given in 2020. You can look at the paper and then you revise it, and you will be able to see that these questions that we're talking about will define what the galvanic cell is. And sometimes we ask you to draw the cell itself, which means you will have to draw the two beakers and everything. So it's important, as you are revising now, to as well look at the cell, how it is drawn. Lastly, as I close now, I will say the electrolytic cell. When we are dealing with the electrolytic cell, we are saying panic. We are saying now the positive. Remember, positive on the galvanic cell was cathode. Negative was, you saw, negative 0.76. It was anode for zinc. And copper for copper, positive 0.34. Standard reduction potential. It was cathode. Anode was negative. So in the electrolytic cell, positive becomes anode, negative is cathode. That's why we say panic. Panic stands for positive anode. So it means if you are using a table, the one that is more positive will be your anode, and the one that is more negative will be your cathode. So I hope you get that. This reaction is non-spontaneous. When you say it's non-spontaneous, we are simply saying that it means we must have a direct current source. You can see there, we have a source. And it's no longer two beakers. We no longer have a salt bridge. So it's important for you now to know that, okay, we're now having our one beaker where the reaction is taking place. We only do electrolysis of copper chloride, which in this case, we have done even the experiment on this one. So I'm hoping that you will be remembering this one. Remember, electrolysis is the breaking down. It means we're going to decompose, to break down copper chloride, CuCl2. You will have understood how this was formed. In fact, when copper chloride was formed, copper lost electrons, chlorine gained electrons, and the structure became one structure of copper chloride. That's how it was formed. Now we're going to separate it. For us to break it down, It means chlorine now must be the one to lose electrons and copper must take its electrons back. So that's how this concept goes about. Hence, you will see that chlorine is always on the anode. Chlorine must lose electrons. Chlorine must lose electrons and copper 2 plus must gain those electrons. And hence, on the chlorine side, you will have that. If you go to table 4a, you will be able to see that chlorine is the more positive one. And in this case, we're saying the more positive one must reverse. So you will reverse the reaction of the chlorine, which will give you this reaction. And for the copper, you will now writing it going forward, which will be copper 2 plus 2 electrons forming copper. Then you are able to see that, okay, that's chlorine will lose electrons. 2Cl minus is forming Cl2 plus 2 electrons. We can ask you, as we did in the experiment, to say what are your observation. Your observation, you can see that there's a brown pigment here, which shows that copper is being deposited on this electrode. And then on the other side, what will you see? You will see bubbles. You see the bubbles there? Bubbles means there's a gas that is formed. Please, you must know this observation. And you must be able to write the oxidation half reaction, which is the 2-Cl minus forming Cl2 plus 2 electrons. And you must be able to write the cathode, on the cathode, the reduction half reaction, which is copper 2 plus gaining electrons. And then do the overall, same way as we did with the previous one. I hope you got that one. And then, with no wasting of time, the last one is electroplating. So under this question, you are expecting electrolysis of copper chloride and electroplating. On the electroplating, this is the simplest that you must get and enjoy this. You are having the object, which in this case is a spoon. And you are having a metal, which is in this case is silver. So learners, the spoon is like you are going to paint the spoon. So the spoon does nothing, which means we will take from silver and give to spoon. So what is happening is that where silver is, silver will lose electrons. Remember, the metal must always lose electrons. It doesn't mean that our questions will always be about silver. We can give you any metal. What you have to understand is that the metal must lose electrons and the object, where the object is, the metal ion. So you write silver on the other side, where the spoon is, you write reverse reaction of this one. So you'll write Ag plus an electron forming Ag. So that's all the reaction that is taking place. So the other question that we like to ask here, learners, is explain why the concentration of the electrolyte, this concentration of this electrolyte remains the same. So we're saying the concentration of the electrolyte, which is silver nitrate, our electrolyte is silver nitrate, its concentration remains constant. This one I can't live without telling you. Its concentration remains constant. Why? Because the rate of oxidation is equals to rate of reduction. Please don't forget that. So under this one, we're saying we have a metal and an object. The metal will lose electron, and then to form the metal ion. The metal ion will gain electrons. So you write a loss of electron. Where there is a metal, there will be loss of electrons. Where there is an object, there will be gaining of electrons. It means the metal loses electrons. On the other side, you just write the reverse reaction. You write this reaction starting from that side, going backward. So learners, without any wasting of time, I would like to say, as you prepare yourself for your exams, please understand. And we are saying here, the metal can be nickel, we can use gold, we can use any metal. But what we have to understand is that the metal must lose electrons. And on the cathode side, you just write the reverse reaction of what you have written. So I would like to say thank you for watching this lesson. See you next time. Goodbye.